Hi, we're going to discuss the basic properties of a wave. A wave is a repeating disturbance that transfers energy through matter or space, or it can also be defined as a disturbance that travels through a medium from one location to another location. So, for a wave to occur, there has to be some sort of disturbance, and that disturbance has to repeat through a medium from one location to another. This definition can be illustrated in a wave done at a football game. Now, in this wave, one person lifts their hand up in the air and puts it down. This is a disturbance. And then people down the row or column repeat the same motion. This is the repetition. And this is done through a medium, which is the people, from one location to another location. This is an example of a wave. There are two types of wave: transverse wave and longitudinal wave. In a transverse wave, particles of medium move perpendicular to the direction the wave travels. An example of this is an ocean wave. In a longitudinal wave, particles of a medium move parallel to the direction the wave travels. An example of this is a sound wave. Now let's look at the parts of a wave. A wave has a crest, which is a point on a wave where the displacement of the medium is at a maximum. This is the crest. And waves also have a trough, which is a point on a wave where the displacement of the medium is at a minimum. This is the trough. Waves also have an amplitude, which is wave measured from its equilibrium position. The height of a wave measured from its equilibrium position. So if this is the equilibrium position, then from this to here to the crest is an amplitude. And from equilibrium position to the trough is another amplitude. Waves also have a wavelength, which is represented by lambda. Wavelength is distance from crest to crest or trough to trough. Waves also have frequency represented by f, period represented by t, and velocity represented by v. Frequency of a wave is how many cycles can happen in a certain amount of time, cycles per second. And period of a wave is amount of time it takes for one cycle to complete, seconds per cycle. So if you examine this definition, you find that frequency and period are inversely related. So then a formula can be derived for frequency as F equals 1 over period. And another formula for period as equal to 1 over frequency. And the velocity of a wave, v, is distance traveled by a cyclic motion per unit time. And the formula for velocity or speed can be derived as wavelength over period. Now we know that wavelength over period. We know that 1 over period is also equal to frequency. So we find that speed is also equal to wavelength times frequency. And so represent this in this formula as v, velocity, equals frequency, f, times wavelength, lambda. And so now that we know this equation and the properties discussed, we can apply the concept. In this example, the sinusoidal wave shown in the figure below is traveling in the positive x direction and has a frequency 21.4 hertz. Find the amplitude. Now we know that the amplitude is distance from equilibrium position to the crest or trough. And over here, the number given is 8.26, distance from crest to trough. So we would want to divide this number in order to get distance from equilibrium position to the crest or trough. Now, before we begin, let's convert these numbers to meters. 8.26 divided by 100 is equal to 0.0826 meters. And 5.20 divided by 100 is equal to 0.0520 meters. So to find the amplitude, we divide 0.0826 by 2 to get 0.01. 0.0413. And to find the wavelength, we would have to double this because this is half of a wavelength. This is distance from crest to trough instead of crest to crest. So we double it and we get 0.104 meters. And to find a period, we know that period is 1 over frequency, and frequency is given. So we find that T period is equal to 1 over frequency, which is 21.4, which will be equal to 0.046 seconds. Seconds is the unit for period. And now we find the speed of the wave. We know the speed is equal to frequency times lambda. And we are given frequency and we just found lambda. So then we derive V as equal to frequency 21.4 times lambda 0.104. And then we find that velocity is equal to 2.22 meters per second, which is the units for velocity. This ends our discussion of properties of a wave.